All right, so welcome to the penultimate lesson of calculus. Penultimate again means second to last, okay? So we're going to do indefinite integrals. We're also going to talk a little bit about definite integrals. Before we talk about integrals, let's go over what we've been doing so far. So if we have a function, y is equal to x squared, and we're finding the derivative, which is dy dx. Remember, you take the exponent, bring it to the front, right? There's an imaginary 1 there, so 2 times 1 is equal to 2. And then you bring down the variable, and then you do 1 less than the exponent. So 2 minus 1 is 1. So the derivative of x squared is just simply 2x, okay? So today, what we're going to do is we are going to go backwards, okay? So we're going to do something called an antiderivative. Antiderivative. So antiderivative is the same thing as an integral, and we talked about this during Introduction to Calculus, because integrals and derivatives are the two major concepts with calculus, okay? So what is an antiderivative or antidifferentiation is basically we're starting out with the derivative and we're finding out what the original function is, okay? We're finding out what f of x is. So how do we do derivatives? Derivatives is the same thing as an integral. You need to have a function f of x, and then you write down what's the variable. So the x, the input is x, so we're going to put dx, which is respect to the x variable. All right, so integration is area under a curve. We talked about this in Introduction to Calculus. So for example, if we have a function that looks something like this, like a straight line, and we're looking to find the integral or the area under a curve from 0, this is our start, and this is our end. So we're looking to find the integral of f of x dx from 0 to 2. Um, all you have to do is area of this is a rectangle, and to find the area of this rectangle, all you have to do is length times width or base times height. So 2, right? This is 2, this is 2, so 2 times 2 is equal to 4. So our integral or our area is 4, okay? But what if we have a curved graph, right? We have something that looks like this. So how do you find the integral of that? Okay, so we talked about what you could do is you could make a series of little trapezoids. My drawing is not going to be as accurate as I want it, but I'm not doing a horrible job, right? You could find a series of trapezoids and find the area of each of these infinitely small number of trapezoids, add them together, and that can give you the area under the curve. So this is for f of x, okay? The integral f of x dx. All right. So we're going to go through and do a couple of examples. There are definitely tricks for this. So indefinite integral, right, is different than definite integral. Definite integral is like when you know what your lower bound and your upper bound is, and you're looking for the derivative, you're looking for the function. And indefinite is when you don't know where it is that you start and where you end, okay? So this here is in the formula booklet. It will be given to you, but just like derivatives, I want us to do as many problems as we can so that this becomes a little bit more like second nature. Okay, so we're going to go through a problem. So all you do to find the integral of the function is you take the variable, put it out in front, take the exponent, and now instead of subtracting 1, we're going to add 1. And whatever we do there, we're also going to put that as the denominator of n plus 1. And you're always going to put plus c. So we're going to talk about why we put the plus c. And again, indefinite integral is when you don't have any the bounds. And right now we're just going to learn integration. Okay, so we're going to go back to our old example that we did before, which is y equals x squared. So the derivative of dy dx is, right, equal to 2x. So for antiderivative, or the integral, again, we're going to go backwards, okay? So we're looking for the integral of our function, which is 2x, and we always got to put what we're finding respect to, so our variable is x. And so to do this, let's go ahead and do our little rule. So the rule is you take the exponent, so in this case, our exponent is 1, and we're going to add 1 to that number. Okay, so before we do that, let's put the 2x down. So we have 2x, take the exponent, add 1 to that, right? So 1 plus 1 is 2. So this same number, right, the 2 also goes on the bottom, and you have to put the plus c. So we'll talk about why we use the plus c in a second. But how do you simplify this, right? 2 divided by 2 cancels each other out, and we're just left with x squared plus c. Okay, so just like here, we started out with our function, which is y equals x squared. When we find the derivative, we get 2x, right? So the antiderivative is now we're going to go backwards. So to do that again, just to kind of recap, you take your coefficient and your variable, put them down, take the exponent, add 1 to it, so 1 plus 1 is 2, and this same 2 goes on the bottom, the 2's cancel out, and so it's going to be x squared plus c. Okay, why do we use the c? Let's kind of talk about that a little bit. If our function, instead of just straight x squared, where we had x squared plus 3, and we're finding the derivative of that, so dy dx, the derivative of x squared plus 3, 2 comes out to the front, so that's a 2, still x, 2 minus 1 is 1. And when we find the derivative of this 3, right, it's 0. I think we did this enough, right? When you have just a number by itself, the derivative of that is just 0. So that's what the c stands for. The c could be any number, right? Instead of 3, I could have put an 8, and the derivative of 8 is still 0. So that would also disappear. I could put 8 million, okay? So this c represents a constant, and you have to put that there for integrals, all right? And this is just like a little quick note. When you take the derivative of c, it disappears since it's a constant, okay? So we're going to go ahead and do a couple of examples just to make sure that you're familiar with this. Before we move on, if you still don't get why the c is there, just call me over and let me go through and explain it to you, okay? So we have a function here, and we are now looking for the derivative, not the derivative, we're looking for the integral, okay? And we don't know what our bound is, like we don't know where we're starting, where we're ending, so this is an indefinite integral. So we're looking for the integral of f of x dx, and let's go through and apply that rule that's in our formula booklet. So here again, right, we're going to write 5x down. There's an imaginary 1 here, so we're going to take that exponent, we're going to add 1 to it and get 2, and that same number goes on the bottom. Okay, let's go ahead and do the integral of x squared, right? Add 1 to 2, so that's going to be x to the third, and we're dividing by 3. And over here, we're finding the integral of this, right? So this is the same thing as x to the 0 power. So we're going to add 1 to that 0, which is going to give us 1. So I'm going to go ahead and write that 1 down. And so this is going to be x to the, right? We're adding 1 to 0, so that's going to give us a 1. And we're dividing by that same exponent on the bottom. All right, and remember, we cannot forget the plus c part. And now let's take this expression that we have right here, and let's just go ahead and simplify it. So 5 over 2 cannot reduce, so we can leave it as 5 over 2 x squared. And then over here we have x to the third divided by 3, right? We can't simplify that as well, so we could leave that. The 1's cancel out, so this is x to the first, which we can just leave it as plus, why did I put an equal sign? This is plus x, and then plus c. So the integral of f of x dx is equal to 5 over 2 x squared plus x to the third over 3 plus x plus c. I do want to show you that I can check my work just to make sure that we're correct. So if I want, this is the antiderivative, right, or the integral. So to see if it's correct, I can just go ahead and take this and find the derivative of this, right? So the 2 would come out in the front, which means that the 2 here and the 2 here would cancel. So this is just going to be 5x, and I take the exponent, subtract 1, so there's an imaginary 1 there, plus I take the 3, bring that to the front, 3 divided by 3 cancels out as well, so I'm just left with x, and then I subtract 1 from the exponent, which is going to be 2, plus find the derivative of this, right? 1 times 1 is just 1. And then 1 minus 1 is 0, so that's going to be just 1. And then the c, whatever the derivative of the c is just going to cancel out. And that's what I have originally, right? Like right over here, I have 5x plus x squared plus 1. Okay, so this is how I can check my work to see if I'm right, right? But this is the actual answer. This is the derivative, the integral. Keep saying derivative. Okay, so how do you find out what the constant term c is? So you can't find it unless they're giving you some more information. So I'm going to go through another problem with you to make sure that this is solid. All right, so in this case, I am given my derivative and I'm looking for my original function. So I'm looking for f of x. And to do that, right, just like we did over here from the beginning of the lesson, right? When we're given our function, we can find the derivative of it. When we are looking for the derivative, when we have the derivative and we're looking for the actual function, we're going to find the integral of it, okay? So we're going to go ahead and find the integral of the function that's here. So to do that, we're finding the integral of 3x squared plus 2x dx. Okay, don't forget to write the dx. So how do we do that? Okay, so remember, you take the function that we have, right? You have 3x here. You're going to take the exponent, you're going to add 1 to it. So 2 plus 1 is 3. And then you're going to divide by that same number. Okay, and then over here, you're going to do the same thing. There's an imaginary 1 here. We're going to write the 2x down first. We're going to add 1 to the 1, which is 2, and divide by the same number. Cool. And then don't forget to write the plus c. All right, so now the cool thing that happens is certain things cancel out, right? So the 3 divided by 3 cancel out, so you're just left with x to the third plus 2 divided by 2 cancels out, and we're just left with x squared, and then we have a c. Okay, so far right now we know that f of x is equal to x cubed plus x squared plus c. So now they're asking us to find, so we found f of x, right? And let's go ahead and see if we can find out what the c is. So to do that, they gave us one more piece of information. They told us that when you have an input of 2, or your x is 2, that's telling you, so when x is equal to 2, your f of x, which is your y, is equal to 5, okay? So all we have to do now is take wherever we see our x, we're going to plug in the number 2. So I have f of 2 is equal to, so x is 2 here, so 2 to the third power plus, x is 2 again, so we have 2 to the second power plus c. And we know that f of 2, right, this part right here, is equal to 5. So let's go ahead and replace this right here with the number 5. And now we're just going to go ahead and solve. Let me just take this up here. So 5 is equal to 2 to the third. Let me just go ahead and simplify that. 2 times 2 times 2 is 8, plus 2 squared. 2 times 2 is 4, plus c. This right here, 8 plus 4 is equal to 12. So 5 is equal to 12 plus c. Subtract 12 from both sides, minus 12. And I know that c is equal to -7. Okay, so I found out what c is. Perfect. So you can only find c when given some more information. Okay, we're going to go ahead and just refresh our memory of definite integrals. Doing calculus is integrate. All right, so I think we've done definite integrals enough that we get an idea of it, but we'll just go ahead and just refresh our memory. So definite integrals, we're looking for area under a curve, but in this case, we're actually given where it is that we start and where it is that we end. So let's just say we call this A and we call this B. What we're looking for is the area under this curve all the way through from the function to the x-axis. Okay, so that's what we're looking for. So we're looking for the integral of f of x dx, and we're starting at A, going to B, and you don't need to put the plus c because, or all of that business, because we're given where we start and where it is that we're ending. So this is in the formula booklet. instead of calling it f of x, they called it y. Same thing, right? And pro tip is definitely always write out the integral. Even if you're going to use your calculator, we talked about trying to get as many full points as possible. And for method, right? So when it says find, you have to definitely like go through and show work, okay? So in this case right here, it says find the area between f of x and the x-axis, right? So what we're looking for is the integral of the f of x, which is x squared dx. And they're telling us that the start is from 0 and the end is from 1, right? So we're going to go ahead, take our calculator. To do integral, remember it's math, and then option number 9 is FN integration. So we're going to go ahead and hit that. Remember, we're starting at 0 right here, it's given to us, and we're ending at 1. And we're going to go ahead and put our function in, which is x squared, right? So x squared, and then don't forget to put dx, okay? And then you just hit enter, and it's going to give us a number. We could take this and hit math. Option number 1 is changing it to a fraction. So we plug that in, and we get 1/3. So just real quick, visually, what is it that we just found? We found out that from 0, so let's just call this 1, right? The area under this curve from the curve to the x-axis right there is equal to 1/3. We just found that out, right? So that area visually is 1/3 because we're starting at 0, going to 1, and we're finding the integration of x squared, which is 1/3. I'm going to do one more question before we do some IB problems. So f of x is equal to x squared minus x. We're finding the area of the curve, which again is integration, right? Integration from 2 to 3. We're going to go ahead and put our function down, which is x squared minus x. Don't forget the dx part, and then this is straight calculate. Right, so I went ahead and plugged it in, right? Exactly what I wrote over here. And I got 3.83 repeating. So I'm going to hit math. Option number 1 is fraction. And it tells us that that is the same thing as 23/6. So 23/6 is this area right here from 2 to 3 of the function to the x-axis. All right, so first IB question, they're telling us a curve passes through this point. So the first number is our x, second number is our y, and they're saying that it has a gradient of, and they gave us the derivative, okay? So find the gradient of the curve at point P, right? So that just means that we're going to take 2, which is our x, and we're going to plug it in for this x right here because they're already giving us the formula for the gradient. So it's just going to be 4 times 2 minus 3. Okay? So 4 times 2 is 8, minus 3 is equal to 5. That 2 points was light. All right? Find the equation of the tangent. So to do that, we have to write down y minus y1 is equal to m parentheses x minus x1. That's the formula for, it's like point slope formula. So we already know that our points, let me just kind of go back and make sure that we write this. Maybe it's a little bit too light, but x is 2 and y is 7. So I'm just going to go ahead and take that and plug that in. So I have y minus, my y1 is 7, right? That's our y coordinate, is equal to, we just figured out that our gradient or our slope is 5. So I'm going to plug 5 in, x minus, and our x coordinate is 2. Okay, so I can go ahead and simplify this. So y minus 7 is equal to distributive property, 5x minus 10, add 7 to both sides, and I get y is equal to 5x minus 3. Okay, so there is the answer to part B. And then for part C, it says, now determine the equation of the curve. So it's asking us to find out what is f of x, right? So they gave us f prime of x. What did we just learn right now, right? So if they give us the derivative to find out what the f of x is, we need to take the integral, okay? So we need to do integral of, right? our function, which is 4x minus 3 dx. So let's go ahead and find the integral of this, right? So to do that, we're going to go ahead and take our exponent, which is 1. We're going to add 1 to it and get 2. So that's going to be, still going to write the 4x. So this is going to be a squared, and we're dividing by that same number, which is 2. And then over here, there's no number next to the 3. This is x to the 0 power. Don't forget the dx part. So I'm going to add 1 to that exponent. So 0 plus 1 is 1, and I'm dividing by that same number, right? And don't forget when I'm finding the derivative to put the plus c. And we can go ahead and simplify this, right? 4 divided by 2 is 2. So this is going to be 2x squared. So we're good with that. Over here we have a minus sign. 3 divided by 1 is 3x. We don't need to put the 1 right there, and we do need to put the plus c. Okay, so that is what f of x is equal to. So we found the equation of our curve, right? Once we derive or we find the derivative, let's go ahead and see if we can find out what c is. So they did go ahead and give us the point, right, which is 2 comma 7. So when x is 2, then y is 7. So all we're going to do here is go ahead and plug this in. So let's do that and find out what c is. So our y, f of x is the same thing as y. So I'm going to put 7 equals, right? I have 2x squared. Instead of our x, what am I putting, right? I'm putting the x value, which is 2. So 2 times 2 squared minus 3 times 2 plus c. All right, so I'm going to go ahead and find out how I can simplify this. So 2 squared is 4, times 2 is 8. So this is equal to 8. And then I have 3 times 2 is 6, so it's minus 6 plus c is equal to 7. So straightforward, 8 minus 6 is 2. So 7 is equal to 2 plus c. Subtract 2 from both sides, minus 2 minus 2. So 5 is equal to c. Okay, so now let's go ahead and put, instead of this c, let's go ahead and put the number 5 in, right? So f of x is equal to 2x squared minus 3x, and c is now 5, so I put plus 5. So there is our actual function. Okay, awesome. Question number 2. This is very similar to question number 1. You should probably pause the video and just go ahead and try this yourself. Okay, so find the gradient of the curve at point M. They do give us our x and they give us our y. So just like we did before, we're finding f prime of, in this case, our x is -1. So we're taking -1 and plugging it in here. So -6 times -1 plus 2. That's 6 plus 2, which is equal to 8. Right, so that's our 2 points. Part B, find the equation of the tangent. So let's start with our point slope. So we have our coordinate right here. So y minus y1 is 4 is equal to, we just found the slope is 8. X minus x1 is -1. Negative negative becomes a positive. So that's going to be y minus 4 is equal to 8 parentheses x plus 1. Distribute that. So that's going to give us 8x plus 8, y minus 4. Add 4 to both sides. And you get y is equal to 8x plus 12. Okay, so that is the equation of the tangent to the curve at point M. And part C, determine the equation of the curve. So they give us that the derivative is -6x plus 2. So for part C, we're going to find the integral of -6x plus 2 dx. So to do that again, you're going to go ahead and take the exponent, add 1 to it. So it's going to be negative 6x squared divided by 2 plus 2, right? This is x to the 0 power. So 2x, add 1, divide by 1, and then we're going to put our plus c there. We're just going to hold our space. Negative 6 divided by 2 is equal to negative 3x squared. 2 divided by 1 is equal to 2. Don't forget the x and the plus c. So let's go ahead, and this is now f of x. Okay, so let's go ahead and find out what our c is. So to do that, we're going to go ahead and plug in our point, right? Go back to what they gave us originally. So f of x, or y, is equal to 4, is equal to negative 3. Our x is negative 1 squared plus 2 times negative 1 plus c. So we're going to go ahead and solve this. Negative 1 squared is 1. 1 times negative 3 is equal to negative 3. 2 times negative 1 is negative 2 plus c is equal to 4. Combine like terms, so that's going to give us negative 5 plus c equals 4. Add 5 to both sides, and you get c is equal to 9. Okay, so now final answer, f of x is equal to, right? We have our function right here. So that's negative 3x squared plus 2x. And instead of the c right here, we found that c is 9. So that is our whole function. And that is our answer for part C. Okay. Last question. At a horizontal width of x equals 30. So what we're going to do is wherever we see our x, we're going to plug 30 in to find out what the vertical height is. So we're going to have is equal to 30 squared times 90 minus 30 all over 1800. And this is something that you can plug into the calculator and get 30. So this is in centimeters. So 30 centimeters, all right? For part A2, the gradient of the mound of the curve at this point. So we're going to go ahead and find the derivative of our function. Just for sake of space, I erased the other one, so forgive me. So this is all over 1800. There's an imaginary 1 here, so I can rewrite this as 1 over 1800 x squared times 90 minus x. I can actually take this and make this a little bit better. Yeah, we can go ahead and FOIL this out, right? So distribute here. So this is 1 over 1800. X squared times 90 is 90x squared. X squared times negative x is negative x to the third. Okay, so why am I doing that? I'm doing that because here I'm looking for the derivative. So dy dx or y prime, either way. And I'm finding the derivative of this function right here. So how do we do that, right? We take our 2, we multiply it by whatever is in front. So over here I have 1 over the 1800. I'm going to go ahead and leave that. 2 times 90, when I multiply that, I'm going to get 180x, right? 2 minus 1 is 1. And then this is minus x to the third, right? So 3 comes out in front, so that's 3x squared. Okay, so I can take this and simplify this a little bit better. So I have 1800. All right, so I'm finding the gradient of the mound curve at this point. That's where x is equal to 30. So I just went ahead in my calculator, put 1 over 1800 times, right, parentheses, 180 times 30 minus 3 times, right, every time I see an x, I'm plugging the number 30 in, squared. And when I do that, I get 3/2 as my answer, right, for the gradient of the curve. So that is the answer to part 2. So that is 3/2, and that would give us our full 4 points with both those parts, right? For part B. All right, so what I'm doing for part B is I'm taking my derivative and setting it equal to 0, right? So you're taking 1 over 1800, parentheses 180x minus 3x squared, setting it equal to 0. So y1 is the function, the derivative, and y2 is 0. I went ahead and hit graph, and I see that x looks like it's intersecting here, and it's going up, and it's going to come back around. So I'm going to go ahead and adjust my window. Let's go ahead and change it so I can see what happens to the right. Let's just go 100 and then see what happens to my curve. So, okay, it goes up, and at some point, boom, it comes back down. So I'm looking to see what this point is right here. So to do that, all I have to do is hit second trace. Option number 5 is intersection, right? So I go over to closer to where they intersect, which is going to be somewhere around there. Enter, 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 and it gives me that they intersect at 60. Okay, so what does that mean? We're going to go ahead and just write x. So find the value of x, which corresponds to the maximum of the vertical height. So x is equal to 60, and that's going to be our answer for part B1. Okay. For part B2, hence find the maximum vertical height, right? So when x equals 60, we're looking for what is our y. So to do that, I can go ahead and see what that's going to equal, right? So I'm going to take it and plug it back into my original function. So if x equals 60, we're going to plug it back into the original function, which is right here. So I'm going to find out what the y is, right, by plugging it right in here. So I have my calculator. So I just plugged in 60 wherever I saw my x in my original function. And then when you hit enter, if x equals 60, then y equals 60 in this case. So y is equal to 60 as well. So that is the maximum vertical height, and that's going to be 60 centimeters. Okay, so that is our answer for B2. Next one says calculate the cross-sectional area of the mound, rounding your answer to 1 decimal place. So to do that, we are looking for, let me see if I can get some space here. Part C, we are looking for the integration of our function, which is x squared 90 minus x over 1800 dx. So we're looking for it from 0, and then the highest value, the cross-sectional area of the mound, is going to be 90. So we're looking to find out what is the integration from 0 to 90 of this function. Okay. Before I show you how to plug that into the calculator, which I think you know how to do, the reason why it's still 90 is right. This is where the cross section starts. This is where it ends. So from 0 to 90 is going to, that's our lower bound. That's where we're starting. That's our higher bound. Okay. All right. So I just went ahead, plugged that into my calculator from 0 to 90, plugged in the function, and I got 3037.5. So that is going to be my final answer. All right, so 3037.5 centimeters squared because it's area, okay? For part D, I know this question's a lot, but let's go through it. So to find n, we're looking for n here. We're gonna let y equals, right? They told us that y here is 30, and we're looking to find out what a is, right? Which is the variable right there. So to do that, we're going to take our original function, which is x squared parentheses 90 minus x all over 1800, and we are going to set that equal to 30 because we know that the y is equal to 30, so we're looking to find out what the x is. So here, you cross multiply here, so that's going to give us x squared parentheses 90 minus x is equal to 54,000. That makes sense. And then you can use the calculator for this part right here. Set this, you can distribute here. So x squared times 90 is 90x squared minus x to the third is equal to 54,000. 54,000. And I'm going to show you how to do this on the calculator. All right, so the first thing we're going to do is plug in y1, which is whatever's on the left side of the equal sign. Whatever's on the right side of the equal sign, we're going to plug this under y2. and we're looking to see where they intersect. So if you just hit zoom, you won't see anything because this is 54,000. So you want to hit zoom. Option number 0 is something called zoom fit. So you're going to see something that looks like this. All right, so you can see we're looking to see where they intersect. So somewhere to the left, but since we don't want any negative numbers, I don't really care about that. I want to find out what value or values are here to the right. So I'm going to go ahead to my window and to my X max. Let's just be dramatic and just put like 200 and see what it is that we see. Okay, so it goes, bounces up, comes back down. Okay, so I'm looking to see where it is that it hits, and so it hits 1, 2 right there. Let me just go ahead and go to my window and change my Y max. So that is right at 54,000. I'm going to go ahead and change this so I can see a little bit more to 54,500, sure. So I can see what the whole graph looks like. So there's my Y1 and there's my Y2, okay? So I already know that this point right here, like when I hit second trace, option number 5, right? I'm looking to see where my, so this is at 95. Let's go ahead and see what this is going to be. Let's go to the left. There we go. All right, so somewhere around here, I'm going to hit enter, 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 and it gives me 30, right? Which I already know. 30, it definitely crosses. So I already know that this here, x is equal to 30. So I'm going to go ahead and hit second trace again, option number 5, and I want to find this point right here. I want to find out what that second point is. So let's go to the right, keep going until I see where it crosses. There we go. Somewhere right around there. So I'm going to hit enter, 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 and that is the point that I'm looking for. So it looks like x is about 82. So x here is about 82. And then to find out what my y is, let's go back. My y is 54,000, right? So here we have 82. That's where our point is, the coordinates of n. And then we want to know what the y coordinate is 30. So the coordinates of point n are going to be 82 comma 30. And that is the A, which is what we just found. Okay. We're almost done. One more part. So part E, they're telling us that to find out the values of P, Q, and R. All right, so for the last part, it's telling us that the cross-sectional area removed by the child can be expressed by this whole thing, and they're asking us to find out P, Q, and R represents the area of that rectangle right here. So we can tell that the child starts at this point right here, which is 30. From 30 to, and we just found out that n right here is 82. So P is going to equal 30. That's the lower bound, right? That's this number right here. Q represents the higher bound, which is point A, which is, we just found out that that's 82. So Q is 82. So we found out 2 of the things that we need so far. And now we're looking for the R, which is the area of this rectangle right here. Okay. So we can do that, right? So area is equal to length times width. Area equals length times width. So we know here that the height here is 30, and we're looking for this distance right here. So we know that this part is 82, and this part right here is 30, right? So to find out this distance, 82 minus 30. So 82 minus 30 is going to give us the length. The width is 30, so we're going to multiply that by 30. That's not bad to do. So 82 minus 30 times 30, when you plug that into the calculator, is going to be 1560. So the area of this rectangle right here is going to be 1560. So that is what R represents. So R is equal to 1560. And we've answered all of the parts of our question and gotten all 17 points. Awesome. Great job. This last question was a wowzer, but 1 and 2 you should definitely be able to be comfortable with. Let me know if you get stuck along the way.